not all meteorites just sit in museums. Some hold secrets that even scientists struggle to explain. Take the Wedderburn meteorite, a small, iron-rich rock found near a remote Australian town. At first glance it looked like any other space rock, dark, heavy, metallic. But once researchers cut it open, they found something no one had ever seen before. Inside was a mysterious metal, a substance that didn't exist anywhere on Earth, edscotite. It had a strange crystalline structure, something that could only form under extreme conditions, likely deep within the core of an ancient planet that no longer exists. This wasn't just some rare metal, it was completely alien. Scientists have tried to recreate it in labs, but natural edscotite still holds secrets they can't crack. Was it a piece of a destroyed planet, a fragment from an unknown celestial body? No one knows for sure. But this tiny meteorite is proof that space holds materials beyond anything found on Earth. If some meteorites hold strange metals, what else could be hidden inside space rocks? In 2000, a collector near Fukang, China, stumbled upon something that defied expectations. It looked like an ordinary iron-nickel meteorite on the outside, but when a piece was cut open, light poured through it. Embedded within the metal were countless golden-yellow crystals. Olivine, a mineral that, on Earth, is often found deep beneath the surface. The result? A mesmerizing glass-like mosaic that looked almost too perfect to be natural. Meteorites like this are called pallasites, but Fukang is in a league of its own. Its structure is eerily precise, with metal and crystal locked together in a way that suggests something more than chance. Some speculate that pallasites are remnants of destroyed planets, shattered celestial bodies that once had molten cores and solid surfaces, like Earth. If that's true, then the Fukang meteorite could be a window into the violent history of the solar system. Or maybe, just maybe, it's something else entirely, a relic from a place we still don't understand. But even the Fukang meteorite pales in comparison to the next discovery. Because while this rock dazzled scientists with its beauty, another meteorite left them with only questions. Some believe it shouldn't even exist. A meteorite shouldn't break the laws of chemistry, and yet, the Hypatia Stone discovered in Egypt's Libyan desert seems to do just that. At first it looked like a common rock, dark, fractured, nothing extraordinary. But once researchers analyzed its composition, they found something shocking. Unlike any other meteorite ever studied, Hypatia contains elements and minerals that don't match anything in our solar system. Carbon compounds inside the stone are structured in ways never seen before. Some of its chemical signatures are so bizarre that scientists aren't sure where they came from. Theories range from ancient supernova remnants to material older than the sun itself. There's even speculation that it could be evidence of an entirely different type of planetary formation, one that happened outside our own cosmic backyard. And here's the part that keeps scientists awake at night. The Hypatia Stone contains microscopic traces of a strange metallic alloy that some claim looks engineered. Could it be an artifact of something long lost in space? A fragment of an unknown destroyed world? Or, as some whisper in the darker corners of speculation, could it be a sign that something, or someone, once existed beyond our reach? But the mysteries don't stop there. Some meteorites don't just hold unknown elements, some carry the very building blocks of life itself. Some meteorites are valuable because they're rare, others because they're beautiful. But a few are priceless, not for what they look like, but for what they contain. One of them fell near the town of Murchison, Australia, in 1969, and what scientists found inside changed everything. When researchers analyzed the Murchison meteorite, they discovered something astonishing: organic molecules. More than 15 amino acids, the same kind that life on Earth is built from. But that's not all. Some of these compounds were unlike anything found on our planet, and isotope studies suggested they were older than our solar system itself. In other words, the raw materials for life were drifting through space before Earth even existed. This raises an unsettling question. If these molecules can form naturally in space and travel across the cosmos on meteorites, then how much of Earth's own biology came from out there? Could life itself have started not in a bubbling prehistoric ocean, but in the cold vacuum of space, seeded by ancient comets and asteroids? Some scientists believe in panspermia, the idea that life is spread across planets by meteorites like Murchison. And if that's the case, then life out there might not be so different from life down here. And if meteorites can carry organic compounds, what else might they bring? Some hold something even more valuable: water. Most meteorites are dry, scorched from their violent entry into Earth's atmosphere. But the Zag meteorite, discovered in Morocco in 1998, held something completely unexpected: water. And not just microscopic traces. Actual liquid water, trapped inside tiny salt crystals, perfectly preserved since the meteorite formed. This discovery was groundbreaking. Scientists had long suspected that water-rich asteroids might have delivered Earth's oceans billions of years ago. But here was proof, frozen in time, inside a rock from space. Even stranger, the chemical signature of the water didn't match Earth's oceans, suggesting that water on our planet might not be unique at all. If meteorites like Zag contain liquid water, could they also transport something else? Could an asteroid impact billions of years ago have carried not just water, but primitive life to a young, barren Earth? Some researchers believe that microbes, frozen inside space rocks, could survive the journey through space. And if that's true, then life might not just exist somewhere out there. It might be constantly traveling through the universe, waiting to land on the right planet. The more we learn from meteorites, the less Earth looks like a closed system. They carry elements older than our solar system, water from distant asteroids, and the chemistry of life itself. Meteorites often contain iron, nickel, and other metals, but some hold something even more valuable: gold and platinum. In the 19th century, a strange metallic rock was discovered near a remote lake in Chile. The Lake House meteorite, as it came to be known, was no ordinary space rock. When geologists studied its composition, they found something astonishing: high concentrations of precious metals normally buried deep within Earth's crust. This raised a thrilling possibility. Could meteorites be a source of untapped riches? Some asteroids in space are thought to contain vast amounts of platinum, gold, and rare elements. If just one metal-rich asteroid were mined, it could be worth trillions of dollars. Private companies and space agencies are already studying ways to extract metals from space rocks, but this meteorite suggests that valuable materials may have already fallen to Earth. And then comes the real mystery. How did a meteorite like this end up with such a high concentration of precious metals? Some scientists believe it came from the core of a shattered planet, a celestial body that was torn apart billions of years ago. Others suggest that certain asteroids could have formed in metal-rich regions of the solar system, carrying traces of cosmic treasure. But if this meteorite came from a destroyed planet, what else might still be out there? If you could travel back to the birth of the solar system, you would see chaos: gas clouds collapsing, planets colliding, and molten rock forming into new worlds. But you don't need a time machine to witness it. The Allende meteorite, which fell in Mexico in 1969, is literally a relic from that time. What makes Allende so special isn't just its age, it's what's inside. This meteorite contains calcium-aluminum-rich inclusions, tiny grains that are older than the sun itself. These inclusions are the first solid materials to have ever formed in the solar system, offering scientists a direct glimpse into the conditions that existed over 4.5 billion years ago. Some of the elements inside Allende even predate our solar system, coming from long-dead stars that exploded before our sun was even born. This meteorite forces us to rethink everything we know about how planets form. If materials from ancient supernovae are inside meteorites like Allende, then Earth, and everything on it, was built from the remains of distant stars. Every element in our bodies, from the iron in our blood to the calcium in our bones, may have once traveled across the galaxy inside cosmic dust. And here's where things get even stranger. Among these ancient particles, some scientists have found microscopic structures that hint at something unexpected: organic compounds, the kind that form the basis of life. Could life's chemistry have begun not on Earth but inside meteorites like Allende? And if these compounds exist in one meteorite, could they exist in others? Some meteorites hold strange metals. Others contain ancient clues about the origins of life. But one space rock is famous for something else: its sheer, unbelievable size. Discovered in Namibia, the Hoba meteorite is the largest meteorite ever found on Earth, weighing an estimated 66 tons. Unlike most meteorites, which break apart on impact, Hoba somehow remained almost completely intact, resting where it landed over 80,000 years ago. This giant is mostly made of iron and nickel, meaning it's essentially a massive hunk of extraterrestrial metal. But its most fascinating trait is that it never left a crater. Scientists believe its flat shape and shallow entry angle allowed it to slow down enough before hitting the ground, preventing the usual catastrophic explosion. That makes Hypatia one of the few meteorites in history to survive its fall without shattering. Because of its immense weight, it has never been moved. Instead, it was turned into an open-air monument, where visitors can see and even touch an actual piece of space. Standing next to it, you can't help but feel small, like a reminder of how powerful and unpredictable the universe can be. While many meteorites are studied in laboratories, this one remains where nature placed it, a silent but unmatched record holder among Earth's many cosmic visitors. The Hypatia meteorite holds the record for size, but meteorites have done far stranger things than just sit in one place. Some have started huge fires, been buried in Egyptian tombs, and even hit cars. Now let's dive into the wildest meteorite facts ever recorded. Meteorites have been falling to Earth for billions of years, but the first officially recorded fall happened in 1492. In the town of Ensisheim, located in modern-day France, a massive fireball tore through the sky before crashing into a field. The explosion was so loud that people miles away heard it. When villagers found the blackened rock, they had no idea what it was, but they were certain it was important. Word spread quickly, and the rock was taken to the local authorities. Even Emperor Maximilian I got involved, declaring the meteorite a sign from above, and ordering it to be placed in a church for safekeeping. Some pieces were chipped away and given as gifts to noblemen, but the main mass still exists today. Back then, people had no scientific explanation for falling space rocks. Many believed they were messages from God or omens of future events. It wasn't until centuries later that scientists understood meteorites came from space. Most meteorites burn up in the atmosphere, but sometimes one is big enough to leave a mark that lasts for millions of years. Some of the largest impact craters on Earth are so massive that you wouldn't even recognize them from the ground. The biggest of them all is the Redefort crater in South Africa, measuring over 190 miles wide. It was formed by an asteroid that struck Earth over 2 billion years ago, releasing energy equivalent to millions of nuclear bombs. Another record holder is the Chicxulub crater in Mexico. This is the impact that ended the dinosaurs 66 million years ago. The asteroid that created it was at least 6 miles wide and sent shockwaves around the planet. The result was a chain reaction of wildfires, tsunamis, and a long, dark winter that wiped out most life on Earth. These craters are reminders of what space is capable of. Earth still gets hit by space rocks all the time, though most are much smaller. Some leave tiny craters, some explode in the sky, and some land quietly, without anyone even noticing. Every day, Earth is bombarded by meteorites. Most of them are tiny, no bigger than a grain of sand, burning up in the atmosphere before they reach the ground. Scientists estimate that about 17 meteorites large enough to be noticed hit Earth each day, which adds up to over 6,000 per year. Most land in the ocean or remote areas, but once in a while one crashes somewhere unexpected. One of the most famous recent falls was the Chelyabinsk meteorite in 2013. It never even hit the ground as a single piece, but the explosion in the air was powerful enough to shatter windows across 6 cities in Russia. Scientists calculated that the shockwave was stronger than 30 atomic bombs, proving that even small space rocks can cause serious damage. While events like this are rare, they do happen, and sometimes meteorites don't just light up the sky or land in empty fields. Some come crashing straight into our cities, hitting buildings, vehicles, and even people. One unlucky car owner in New York found this out the hard way. Owning a car comes with plenty of risks: accidents, theft, bad weather. But in 1992, a woman in Peekskill, New York, experienced something far less common. Her bright red Chevrolet Malibu was sitting in the driveway when, out of nowhere, a 27-pound meteorite came hurtling from the sky and punched through the trunk. The impact was powerful enough to bend metal and shatter the car's frame, leaving a massive hole in the back. But what makes the Peekskill meteorite so famous isn't just the damage, it's the fact that dozens of people saw it coming. The fireball streaked across the sky for hundreds of miles, and several people captured it on video. The footage helped scientists reconstruct its trajectory, making it one of the most well-documented meteorite falls ever. The owner's luck wasn't all bad. While her car was wrecked, collectors paid thousands for both the meteorite and the damaged vehicle. The car itself was sold to a collector and is now on display at meteorite exhibitions. Not a bad payout for a space rock smashing through your trunk. Meteorites hitting cars might sound rare, but they happen more often than you'd think. And sometimes, a meteorite isn't just a random chunk of rock. Some of them can be traced back to specific places in our solar system, like asteroids. Meteorites don't just appear out of nowhere. Most come from the asteroid belt, a vast region between Mars and Jupiter filled with millions of space rocks. These asteroids have been orbiting the sun for billions of years, colliding with each other, breaking apart, and sometimes getting knocked onto a path that sends them straight toward Earth. Scientists have been able to trace some meteorites back to their asteroid origins. Take Vesta, one of the largest asteroids in the solar system. Fragments from it have been found right here on Earth, proving that pieces of asteroids can survive long journeys through space. Other meteorites come from primitive asteroids that formed in the early solar system, preserving materials from a time before Earth even existed. Studying these space rocks helps scientists understand what asteroids are made of and what resources they might hold. Some asteroids contain valuable metals like platinum and gold, fueling interest in asteroid mining. Others hold water, hinting at the possibility of using them as refueling stations for future space missions. Meteorites aren't just cosmic debris, they're pieces of other worlds, carrying secrets about the past and maybe even the future of space exploration. At first glance, a meteorite might not look any different from an ordinary rock, but scientists have developed reliable ways to tell them apart. One of the biggest clues is fusion crust, a thin, blackened outer layer that forms when a meteorite heats up during its fall through Earth's atmosphere. This crust is usually smooth and can even look glossy in some cases. Another giveaway is density. Meteorites are often much heavier than Earth rocks of the same size because they contain high amounts of iron and nickel. Many of them are also magnetic, making them easy to test with a simple magnet. When cut open, some meteorites reveal Widmanstätten patterns, intricate crystalline structures that don't form naturally on Earth. Then there's chemistry. Some meteorites contain elements in ratios that don't match any known Earth materials. Others have tiny glass-like spheres called chondrules, which formed in the early solar system and don't exist in Earth rocks. With these unique traits, trained experts can instantly recognize a real meteorite. But centuries ago, before scientific testing, some space rocks were mistaken for something much more mysterious, and ended up in ancient tombs. Long before anyone knew what meteorites were, ancient civilizations treated them as sacred objects. In Egypt, archaeologists discovered that some of the earliest iron artifacts weren't made from mined ore, but from meteoritic iron. Beads found in a tomb dating back to 3200 BCE were crafted from space metal, centuries before humans figured out how to smelt iron from the earth. The most famous example is King Tutankhamun's dagger, found in his tomb. Unlike other weapons from the time, its blade was made from iron that fell from the sky. Testing confirmed that the metal's composition matched known meteorites, proving that Egyptians had access to extraterrestrial materials thousands of years ago. They weren't the only ones. Other cultures also prized meteorites, forging them into tools, weapons, and even religious objects. Some Native American tribes believed fallen meteorites were gifts from the gods. Ancient people might not have known where these metals came from, but they recognized their rarity. And they may have been right to think they were special, because Earth itself was shaped by meteorites in ways we're only beginning to understand. The planet we live on today exists because of meteorites. In its earliest days, Earth was constantly bombarded by massive space rocks, some the size of small planets. These impacts were so powerful they melted entire sections of Earth's surface, shaping the planet's geography and atmosphere. One of the biggest theories is that a Mars-sized object slammed into Earth 4.5 billion years ago, creating a cloud of debris that eventually formed the Moon. Later, during a period known as the Late Heavy Bombardment, asteroids rained down on Earth for hundreds of millions of years, possibly bringing water and organic compounds that helped kickstart life. This kind of cosmic violence didn't stop after Earth cooled down. craters left by past meteorite impacts still exist today, some of them buried under oceans and continents. That's about it. Write in the comments what fact about meteorites surprised you the most. For more useful information, watch other videos.